The hidden giant, why just 0.04% of CO₂ in our atmosphere holds the key to Earth's future. The invisible impact of carbon dioxide. Carbon dioxide, CO₂, constitutes only 0.04%, 423 parts per million, ppm, of the Earth's atmosphere, yet it plays an outsized role in controlling the planet's climate. Despite its trace presence, CO₂ is a potent greenhouse gas responsible for trapping heat and driving global warming. Its current rapid increase is a direct result of human activities, such as burning fossil fuels and deforestation. But what if we stopped emitting CO₂ today? Would the atmosphere recover quickly? The answer reveals both the urgency of action and the long-lasting effects of our emissions. The long shadow of carbon, how long would recovery take? Even if humanity reduced its CO₂ emissions to net zero tomorrow, the excess carbon dioxide already in the atmosphere would not disappear overnight. Here's why: natural absorption processes are slow. Oceans, forests, and soils absorb CO₂ from the atmosphere. However, these natural sinks operate on timescales of decades to centuries. For example, oceans currently absorb about 30% of annual CO₂ emissions, but they can only absorb so much without reaching a saturation point. Atmospheric residence time: a single CO₂ molecule can remain in the atmosphere for 300 to 1,000 years, depending on the balance between emissions and absorption by natural systems. This means that even if we stop emitting today, the elevated levels of CO₂ will persist for centuries. Decades for stabilization: if emissions ceased entirely, CO₂ levels would begin to decline slowly. Scientists estimate it would take 20 to 30 years for the rate of increase to halt and natural processes to start reducing levels meaningfully. A full return to pre-industrial levels, 280 ppm, could take hundreds to thousands of years, depending on the effectiveness of natural and artificial carbon removal methods. The climate lag effect. Even with zero emissions, the climate would continue to warm for some time due to the inertia of the system. Oceans store heat. The heat absorbed by the oceans will continue to be released gradually, prolonging global warming effects. Melting ice and sea level rise: these processes, triggered by past emissions, will continue for decades or centuries. Why every year counts. The longer we delay reducing emissions, the more challenging it becomes to stabilize and reverse CO₂ levels. Continuing at the current rate of emissions adds 2.5 to 3 ppm to the atmosphere annually. This cumulative increase raises the likelihood of crossing critical climate thresholds, such as irreversible ice sheet melting or the collapse of major ecosystems like the Amazon rainforest. The path forward: mitigating long-term impacts. To accelerate recovery, humanity must combine immediate emissions reductions with long-term solutions. Massive reforestation: forests can absorb large amounts of CO₂, but it requires decades to restore degraded ecosystems. Carbon removal technologies, direct air capture, DAC, and other innovations can remove CO₂ faster than natural systems alone. Protecting oceans: preventing further warming and acidification ensures that oceans remain effective carbon sinks. A global perspective on time. The timeline for recovery underscores the urgency of action. While reducing emissions is critical to halting the rise of CO₂ levels, addressing the existing excess will require a concerted effort over generations. Every year that emissions continue unchecked adds to the debt humanity owes to the planet, and the longer we delay action, the longer recovery will take.